Good day, guys. How are you doing today? Today we're going to begin from where we stop. So today we're going to be designing the circuit for binary counter application. So how do we begin? We first start by bringing out some components, also connecting them together with our Arduino. You can choose either from Arduino Uno, Mega, or Nano, depending on the number of things required and any other capacity of any equipment to drive the Arduino with. But since it's just a simple application, you can just bring our Uno, our normal Uno out. Let's just open our SimulIDE or Proteus if you have Proteus with you, or you can also use your theme cards and if you are using online platform. Or you can also make use of the PIC SimLab. Now let's firstly bring out the Uno. Let's search for the Uno here. And we'll set it by pressing Ctrl R or Command R. So I'm having the Uno here. Let's build the LED. Let's do a binary counter from counting from 0 to 15. Let's start from it. Let's just start for LED. I'm going to bring out 4 LED. Fourth LED, the second LED, and the third LED, and the fourth one. Then we also have that should do for now. So later on we can also increase the capacity of our applications, and let's do something about it. Let's select this. Let's also bring out some resistor. Let's bring out DIP resistor. You can also use your normal resistor, but let's make use of the DIP resistor. Let's just bring the DIP resistor here. Now we can rotate. Let's just rotate them. Let's just rotate this. Select them and rotate. Then so this is our cathode side, this is our anode side. So now let's zoom it. Let's also bring out the ground. Let's zoom in. Zoom to fit. Then you can bring them. Select them and drag them into the middle. Then this is 8 pins. So we just need 4 pins. Properties and select 4. Then you can also rotate this. If you want, the first one goes to the cathode side. From cathode to one of the resistor. This is just a resistor IC. The DIP means dual inline packaging. So we connect them together. So we now connect this to the ground. So voice. Join them together. So our resistor is not polarized, so you can just join them together. That is it. Okay. Let's connect. Let's start from 2. Let's start from this. Start from this. The second pin, same thing too. So we have this. So So good. Here we go now. Then we can save this. We can save this to anyone, to anywhere we want. You can save it. You'll have the project here. The project here. Right swipe. Maybe, sorry, let me come back. I have white pieces. Yes. Then you can have our new folder binary count. Bin count. Just name it with this. Binary count 1. Circuit 1. Then save it. Then we can also bring out our Arduino IDE. I just open the Arduino IDE code. IDE. And just launch it now. Trying to bring it out. Yes, okay. Then these are our default functions. So now this is our setup where we configure our pins. So now let's create the port pins. What port are we making use of? We have port 2, 3, 4, and 5. So let's port 2, 3, 4, 5. So I'm not going to be attaching the Arduino device here, but I'm going to compile it to a simulating here. So, but I'm very sure it's going to work in the Arduino Uno device. So, or anyone you are using. So, because in case you have issue with them, please let me know in the comment section. Okay, we also have the constant pins. We're having 4 pins. So let's declare an array. LED pins. So in LED pins is 4, right? Array in C is declared this way. Array with angle bracket, pin 2, pin 3, pin 4, pin 5. We terminate the line. Then we can also have our, let's now get the row now. So the row, these are the pin connections, that the LED pins connections. Let's have our LED values. We can also have constant int LED values. So let's make use of what? We're going to write the code in 2 places. So we're going to use the first one to turn on the gate and turn off the gate. So let's make it, we're going to be having 15 rows. 15 rows and 4 columns. Then the first braces and the second braces. So, but I have the code, the LED code with the binary count variables written down. So I'm going to copy it and paste to reduce the time we're going to spend writing them. So I have them here. I have it here. So we have the number here. This is the number, right? This is 1. Decimal equivalent is comment. Double slash is comment. 2. If you are familiar with binary counting, you should know this is the value binary representation. So we're going to be turning on, because computer work with 0 and 1, we're going to be turning on all the LED to determine. Now that's our first code. The second code, we're going to make use of the what? The BCD equivalent number. So now let's turn it. Let's try now. Let's now set up the pins. We have 4 pins here. So instead of me just making use of the pins, I have a certain number of pins. Pin mode 1, pin mode 2, pin mode 3. Just like a 4 in the range of int I z equals 0. I less than the number of 4 pins. I plus plus want to initialize all the pins at once. Pin mode. Let me check my LED pins is what? LED pins. So we can identify each of these values, each of these pins by the index number. This is index 0, index 1, index 2, index 3 by index. But the value in index 0 is 2, the value in index 1 is 3, the value for the beginner for people. So now let's go. In case you're having issue with C or C+ programming, you can check our playlist as well. We deal with these things a lot. So now LED pins, control space to show you IntelliSense. Then we put our I. Our I will go through the first time I0, I1, I2, I3. So then we initialize what? Output. LED is a what? It's an Apple device. Then we are through with the setup. This function will only run once. Then therefore we come to this place. These are main functions. Let's create, but let's just follow some of the rules. There's something called function prototype. But this is not main function by default. Unlike C, in C or C+ program, you're having a function prototype that you're having a function below the main functions. You have to add the prototype or the same function signature on top of the main. But we have a custom function called loop now. So we can still have our custom function called maybe void display. Let's name it. Now let's look throughout the whole pin and let's begin to turn on each of those pins on one after the other. How many pins do we have? Int I equals 0, I less than 4, I plus plus. Just the same way. But now this is where the things change. Now, how do we write to turn on our LED from our previous code? We turn it on by using the digital, right? Because LED digital turn on digital can take only on or 0. So we use digital, right? Here, not digital read. Digital, right? Which pin are we turning on? We turn on the pins. What LED is at what index? We only have 4, so we can't go beyond 4. Then the second one, and the value. We are going to turn on the LED array. Here, let me explain the array in case you are not used to multi-array. This is the row. For instance, we have how many rows here? 1, 2, 3, 4, 5, 6, up to 15. These are the columns. 1, 2, 3, 4. But by index, they are indexed from 0. Maybe 0, 1, 2, 3, 0, 1, 2, just in form of matrix form. Then, but in matrix is start with 1, but here in our code we start from 0, index base. 0, 0, this is 0, 0. I think yes, even the same thing. I think matrix also the same thing. Yeah, I think it's also start with 0. So 0, 0, 0 is this. Then therefore now let's print out P15 to print out this value and just get maybe 2, 0, 1, 2, 2, 2 to get this value out for us. Therefore, let's print the value. Let's look through this value in 15. So let's print this value out now. Let's get the value here. Mind you, the value here will be the first value for the row will be passed from outside, from the number. Maybe okay. Let's just LED values at what column? Column I. Column I. So column I. But how do we get this value? We pass it from the outside. Number. Maybe the number we want to pass in. We turn in the LED. So then therefore we now put our number here. So the number here will go from 1 to 15. So we're going to pass it from the loop from ourselves. Then we can now go to our main functions. For int I equals 0, can make use of any variable. You can make use of any variables to do that. I less than 15, I, so it's going to start from 0. So the value here is going to start from 0 to 14. Go start from 0 to 14. So 0 to 14 will be how many digits, how many values, we have 15 values there. So then we have I plus plus. We can also use I equal to what? Plus 1. See the same thing. Then we cannot call display here. Display and pass in the value of I there. Let's delay for maybe 1 second. Now, in a previous video, we've explained this display also a lot. It's taking milliseconds. 1 millisecond, that's 1,000. That is 1 over 1,000. So 1,000 over 1,000 will give us 1 second. Then we can, I think our code is right now. I think no error is in the semicolon here. Let's check again. Let's explain this again. We declare how many pins of the LED. We have 4 LED pins. Then we declare we are reading from 1 to 15. So this is the first one, 1 to 15. These are the values here in bit and binary representations. Then we also have, we set up the pins. Our pins, we have to set them to output since they contain the LED. Then therefore, we now write this display function here. Display here is number. So we also look through the 4 columns. We have multiple array here. This 4 here is also causing our column here. The number, how many columns do we have? But this one here, the LED pins here, we turn on the LED pins, the port at which we connect them to. So maybe I should LED pins port. LED pins. Let's just leave it as LED pins. So then we turn it out to make it output here. Since we also have 4 columns, so we look through the 4 columns here. So 4 LEDs. In case we are carrying out multiplexing, then we are going to do the difference between this and this. Now, for now, we now look through the 4 columns. The 4 columns, we pass in, since also the LED pin are the same pins number, we pass in our I. So turn the first LED port on. So we also take the first column here, and the value we passed from here, they can represent from a value from 1 to 15. So since we pass them, so now let's compile our code now. There will be error here. Let me terminate my index with semicolon. Semicolon, this is our array. Start from A and end there. So then compile. Oh, let me save it first. Let me save it inside our then I save it as bin code. So in case you want to use the board straight, you can just select the board and you select the board you want to make use of. And then you, after compile, you upload it. So we have to export the binary S file. The firmware is in S file format. So let's export it to the same folder so that, or else you're not going to see it. Let's just try. After compiling it now, set done compiling, no error. Let's try to upload it here. Come here to your circuit diagram, main diagram here, load firmware. From where? Can you see there is no from our bin code? Can you see we don't see our S file there. There is no S file here. It's in the temporary folder on our system. They are using Windows, you see in your temporary folder. But to export it to where our code is, let me just bring that back. Come to the sketch, export compile binary. So it's already there now. Anytime you compile your code, you have to export it to that binary, to that file. So now let me go back there, load it, load firmware, bin code. Can you see we have build file now, folder. Then you load the X file, I firmware into it. Now power it on. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 1, 2. So that's how it works. Thank you very much. We can also demonstrate the second code. And let me just do it first. In case you don't want to be writing, you are used to hexadecimal values, you can also have the hexadecimal value. Then you can turn on the bait. Maybe I will do that in the next video to prolong this video so long. So I'm going to do that in the next video. Thank you very much. Please like, subscribe, and have a nice time. Thank you.